Welcome to Simplifying Rational Expressions. This is where we will deal with the numerator as well as the denominator and the NPVs, and we will simplify. So the first thing that I just want to do is kind of review what you know or what you knew before. So if we look at 5 over 15, okay, if I asked you to simplify that, you would divide it by 5 over 5. But what we can do is we can break it down. We can factor it, right? 5 is prime, it stays as 5. And then 5 times 3. Well, we know that 5 divided by 5 is 1. And so we're left with 1/3. And I'm showing you that because that's the way that we're going to have to deal with these expressions here. So the next one that I've got is 30 over 18. Okay, so I factored that. Well, we've got a 2 divided by 2 is 1. 3 divided by 3 is 1. And 5 over 3. Okay, so I'm just going to give you some of the basics because sometimes what happens is students have a tendency of, I'm going to say, canceling things out that are not cancelable. So we're going to look at that. So x plus 4 divided by x plus 4. Anytime the numerator is the same as the denominator, that will simplify to 1. And if you're ever unsure, you can always take any value for x, 0, 5, whatever you want, plug it into the numerator, denominator, simplify, and see if that works, right? So same thing divided by the same thing, that will simplify to 1. Now when we're adding, we know that the order doesn't matter, so it doesn't matter if n is 3, right? 3 plus 2 will be the same as 2 plus 3, so that also simplifies to 1. X minus, slide it over a little bit here, x minus 3 over x minus 3, same thing, identical numerator, identical denominator, simplifies to 1. Now, we know that order matter when it comes to division as well as subtraction. So, will this simplify to 1? Well, let's see. Let's choose a value for m. Doesn't really matter. So, we'll go with, let's go with 2. 2 minus 5 over 5 minus 2. Well, what does that give us? That gives us negative 3 divided by 3. What is that? Well, when we have these opposites here, it simplifies, but it doesn't simplify to 1. It simplifies to negative 1. Okay, what about x plus 6 over x minus 6? Well, once again, if you're ever unsure, take a value, substitute it in for x, 9 over negative 3. That doesn't give us 1 or negative 1, so that simplifies to x plus 6 over x minus 6. Okay, and sometimes what students will do here, and I'm showing you this in order to, avoid this issue, is they will cancel out the n's. But don't forget, this is a binomial. Whatever n is, we have to add 7 to it, right? So do not do that, and I'll once again explain why, right? Because this means that simplifies to 7. Well, 3 plus 7 divided by 3 gives us 10 over 3, which is definitely not 7. So that stays as it is. You can see up in the corner here, I have always state the NPVs before simplifying to avoid losing any information about the non-permissible values. And bear with me because we're going to start simplifying here right away. So these ones are already factored for you. These ones down here will have to factor first, okay? So what can I cancel, right? Remember, one has to be in the numerator, one has to be in the denominator. So here we have two identical x plus 5s. It doesn't matter which order, right? We know that with multiplication, order doesn't matter. And I'm left with x minus 4 over x plus 1. Now you might be saying, but you said state the NPVs first, and I didn't do that, did I? Well, here's why. Here's our final answer. But we also have to make sure to take this into consideration as well, right? So NPVs, right? X, now here's where you don't have to write it out anymore, right? So what can't X be? X can't be negative 5, and X can't be negative 1. If you want to write it out and show the steps, then by all means go ahead. So here, what I'll do in this case, now if you simplify it first and you don't do the NPVs right away, you can always go back and do them. You just have to make sure to include all of the non-permissible values, right? So we'll go NPVs. N can't be 1, and N can't be 3 over 2. So what can I cancel? Where do I have my identical factors? Identical, identical. Can I simplify those? No, I can't. So that is my final answer. A little bit more complicated over here, okay? So it doesn't matter where you start. I better start with my NPVs so that I don't forget about them. Whoops. But I'm going to ask, how many NPVs are there? That's my first question. There are 3. Don't forget, this GCF here is a non-permissible value. So M can't be 0. That's the first one. M can't be 2. And M can't be -3. So what can we cancel here? What can we simplify? Well, if I have M times M up here, right, then one of those will cancel. This will give me my -1. So I usually just tuck the negative over here. And I can't simplify anything else. So I have -M times M plus 2 over M plus 3. Right? So I have the steps laid out for you right here. Step number 1, factor numerator and denominator. Identify non-permissible values. Cancel out the expressions in the numerator and denominator that are identical or equivalent to 1 or -1, and then rewrite any remaining expressions in the numerator and denominator. Okay, so factoring first. M minus 6, M plus 2. The nice thing about this is that chances are, because we're simplifying, this is going to be one of the factors. It's not a guarantee, but it sometimes can make it a little bit easier, right? Cancel, cancel. M minus 6. That's our final expression. And our non-permissible value is M can't be -2. Oops, down to this one. Got some GCFs here. 2x, x minus 5 over 4x, x plus 5. Well, 2 divided by 4, that's the same as 1/2, right? X divided by x cancels, and I'm left with x minus 5 over x plus, 2. X plus 5, you have to make sure to read your own writing. Non-permissible values of, going back to this, should have done that first. X can't be 0 and x can't be -5. There we go. Okay, and we've got 3 more here. I'm going to factor them quite quickly. GCF, difficult trinomial. I'm going to go back up here and I'm going to do my NPVs. So x can't be 2 and x can't be -5 over 2, right? That is equivalent to 1, and my final answer is that. Difference of squares, n plus 1, n plus 2, oops, NPVs, n can't be -1, n can't be -2. I'm left with n minus 1, n plus 2. And this last one here, GCF first, 2y squared plus 4y plus 3. difficult trinomial. Excuse me. Then this is also an easy trinomial. And now I'm ready for my NPVs. Just want to make sure that you can see everything. Oh, glad I moved it down. NPVs, y can't be -1/3. I am rewriting this, but if you just wrote comma -3, that's fine. What have we got here? 2y plus 3's. Final answer, 3y plus 1. And that's the end.